You know that feeling when you're deep into a huge research project, and you know a key fact is somewhere in that pile of documents, but you just can't find it?
Oh, absolutely. It's that frustrating mental bottleneck.
Exactly. And for an AI, that's what we call context rot. Even with these massive context windows, the models seem to get, well, dumber as the conversation goes on. They lose the plot.
They do. And that is the problem we're diving into today. There is a new paradigm called recursive language models, or RLMs, that's designed to completely eliminate that bottleneck.
Eliminate it. That sounds ambitious.
It is. We're talking about handling inputs up to 2 orders of magnitude bigger than what we see now. Think 10 million tokens and beyond. This is really the next big step for inference.
Okay, so let's get into the mechanics. How does it work? Because the standard approach is just stuff more and more into the model's memory, right?
Right, which is the problem. The huge shift with RLMs is that you stop doing that. You don't feed the massive prompt directly into the neural network at all.
So where does it go?
It lives in an external environment, basically a symbolic space. The easiest way to think of it is like a simple command line. Technically, it's a Python REPL. The context just sits there as a variable.
A variable. So the main LLM, the root model, doesn't read it passively. It has to actively, investigate it?
Exactly. It becomes an active researcher. It writes and executes code inside that REPL to interact with the context.
So it can use tools like running a search query or using regex to filter things down.
Precisely. It peeks into the context, it slices it, it dices it. It programmatically narrows down that massive search space to find what it actually needs.
And that's where the recursive part comes in, I'm guessing.
That's the magic. The model can write code to define a subtask, and then it invokes a fresh copy of itself, a sub-LM, to go solve just that one piece of the puzzle.
So it's delegating. It's like a manager handing off work.
A perfect analogy. It's context-centric decomposition. It keeps its own working memory clean by delegating the heavy lifting.
And that's really interesting because that whole idea of using agents in code to manage complexity is, well, it's exactly what our sponsor, Embersilk, focuses on.
A great connection.
Yeah. If you or your business needs help figuring out where agents can make the biggest impact, whether that's with AI training, automation, or software integration, you should check out Embersilk at embersilk.com.
So we should talk about the performance because this isn't just a theoretical improvement. The results are pretty dramatic.
Okay, let's hear it.
On a benchmark called OolongPairs, which is incredibly dense, the base models just failed catastrophically. We're talking F1 scores below 0.1%.
So basically zero. They couldn't do the task at all.
Not at all. But when you take those same models and put them inside the RLM framework, the score jumps to as high as 58%.
58. That's not an incremental gain. That's going from impossible to possible.
It's a total game changer. And what's more, it holds up at scale. Even at 10 million tokens, the performance degradation is so much less severe than with any other method. You can understand an entire code repository or, a massive corpus of legal documents.
And is it incredibly expensive? It sounds like it would be.
You'd think so, but no. Because the model is so smart about only looking at what it needs, the average inference cost is actually comparable, sometimes even cheaper than the old brute force methods.
Wow. Okay, so if the model is already making these smart decisions about how to break down a problem, what's the next step?
Well, the most exciting part is that this whole decision-making process is learnable. You can actually train the model to get better at being a manager.
Using reinforcement learning, I imagine.
Absolutely. Training models specifically for this RLM framework could unlock just another level of efficiency and capability. The whole bet here is that LLMs should be the ones to decide how to manage context for themselves.
So we're moving from the model as a passive text completer to an active strategic researcher.
That's the future, yeah. We're getting closer to AI agents that can tackle problems that span not just minutes, but weeks or months. True, long horizon problem solving. It's an incredible leap.
It really is. We're watching AI learn how to think about thinking.
A great way to put it.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.